Okay, I think I am live. Looks like I am. Good evening, everybody, from the warm skies of Death Valley region. My name is Mike Jury, and I am going to be doing some astronomy tonight with a camera and my telescope, and have you along for the ride to show you what I'm doing. So, the first thing that I wanted to go over was what my actual setup is. And let me see if I can put this on the screen. This is my telescope. This is a 6-inch imaging Newtonian, which is a reflector telescope. And it's on a Celestron Evolution AltAz mount. And it's a simple mount, but very effective, and gets me around the sky pretty nicely. And the camera that I'm going to be using tonight, for those who it means something to, is going to be a ZWO ASI 178 MC, and that's usually a planetary camera designed for small, bright objects, but I like using it for DSOs or deep sky objects as well, and so we're going to be looking at other things with it. So that is my setup, real quick there. And so now what we're going to do is actually go see what we can see. So right now our scope is looking at Altair, and we're going to now zoom over, go into my Planetarium program here, which is a planetarium program called Stellarium, and it allows you to see the night sky and all the things in it. And one of the cool things that you can do is you can actually control your telescope from it. And if you have a computerized telescope, that's what you can use it for. And so that's what I'm using it for tonight. So I'm going to pick out the Lagoon Nebula, our first target, and push the hotkey button. And you can probably hear the scope whirring in the background. And we're going to, got to turn this off though. We are going to go to, okay, I think I've got still something set up here. Okay. Okay, why is that still showing on the screen? I don't know, I'll have to fix that later. Okay, anyway, so we're going to send the telescope over to our first object, the Lagoon Nebula. And so let's see if we can get that centered in the screen. And I'll tell you some more about the, okay, so it's kind of the bottom of it's kind of right here. I can just barely faintly see it, so I'm going to move that over just a little bit, bring it more over into the center of the screen. And then we'll try popping it out for a little bit more of an exposure, which should make it a bit more bright. Yeah, there's kind of the bottom of it right there, and that looks like it's placed pretty well. So I will increase our exposure and reset that stretch so it's not completely blown out. And let's see what we get for a live frame. So right now this is basically, I've set the camera to take a 16-second exposure of this area in the sky, and so that is basically a picture of it for the 16-second exposure. And the neat thing about this software is I can then take this software and stack those exposures so that what the software does is it takes one 16-second exposure and it then takes a second one and uses the background stars to align the second one on top of the first one and stacks it on top, and then does a third one and a fourth one and all that stuff. And so what it does is it just keeps stacking more and more 16-second exposures onto the stacked image, and with each image that it adds on, the background noise reduces. As you can see, it's a pretty noisy image right now, and the bright parts get brighter and sharper, and so you end up getting a very clear, or hopefully very clear, image that just gets better and better as you stack more and more exposures, sub-exposures or subs on top of it. And so this is a piece of software called SharpCap. You can see up here in the left-hand corner, and it's a really fabulous, powerful piece of software for doing this kind of thing on the PC. If you're on a Mac, unfortunately, it doesn't work on the Mac, and you have your own things that you can use for that. But for the PC, SharpCap is really fabulous. And so what we'll do is we'll let several frames come in here, and then we'll start doing some histogram adjustments, which will make things look a lot better as well. All right, Gary, good to see you on. John and Kirsten, nice to see you guys. Yeah, Gary, it's probably about 75 here still right now. It's a nice, clear, dark night. The temperatures will cool probably into the mid-50s overnight, but for right now it's actually nice and warm. I'm out in a t-shirt and shorts, and it's pretty comfortable. Toward the end I may sneak inside and get into some sweats or something long sleeve, because it'll actually cool off enough where I'll start getting chilly here. But yeah, it's pretty nice, and thankfully it's the smoke has pretty much cleared here. We've still got a little bit in the air, but not too bad. So doing better than we've been doing for the last, gosh, it's been 2 or 3 months for those not in the area. 2 or 3 months of unending smoke from all the fires here. So now I'm going to start adjusting the histogram, and you can notice the background got a lot darker as I did that. And the histogram allows you to basically adjust. The histogram is basically a map of all the colors that are available on the image, and it allows you to tailor how those colors show up, so you can tweak and tune it to look better. And I'm also going to put a little color into it here, and let it keep. Yeah, that looks a little bit better. And I'll go full screen with it while it's coming in, so we can kind of just see the thing itself without all the software in the way, as it continues to come in and stack more and more images on top, and continues to improve what we're seeing. Yeah, Gary, I think most of it's east of us as well, so it's good to get a relief from the smoke. Yeah, it's starting to come in pretty nicely. I have to jump on this stuff pretty early, and I can't linger too long, because right now this stuff is pretty low in the southwestern sky, and while I have decent horizons, I don't have infinite horizons, so this heads into a roof here pretty quick. So I've got to make sure I start at the southernmost one, which is the Lagoon Nebula, and then I work my way up, and till I get to something I can spend a little more time on. But so that's why this one is going to be first. And yeah, Gary, the 4 little spikes he's talking about on the stars, those are just diffraction spikes. Those are actually caused by the 4 veins on my secondary mirror in the very front of my scope. And it's kind of a traditional way for stars to look, I guess, in pictures. So it's kind of a neat thing. Okay. Let's see how we're doing here on the histogram. So again, this is the Lagoon Nebula, and this is a nebula, bright nebula. It's nestled right in between Scorpius and Sagittarius in the summer sky. And so it's a summer constellation, and right now we can catch the very tail end of these things before they start setting really early in the evening. So you gotta catch them early now, because they're setting earlier and earlier every night as the summer constellations head west and head out of our field of view to make room for the winter constellations that are coming, which have their own spectacular things to show us. But for now we can catch the last part of this, which is pretty neat. And I know Gary, when he adjusts his histogram, he likes to have his black level peak a bit left of this main white peak, the main peak of the histogram. And what that does is it makes the background nice and dark. Some people like to have it a little bit to the left, and that makes the background lighter but shows more of the object. I kind of pick a middle ground, and I try to stay somewhere near the peak itself, and then use the midpoint to kind of adjust how much of the stuff we can actually see that shows up. Makes it a little bit brighter the further left you push it, but if you push it too far, it just makes it really, really noisy, and you can't really see anything. So you got to play kind of a balancing act with it, and sort of put it in a place that shows a lot of the detail, but doesn't bring out a lot of the noise that comes from the camera. Speaking of noise, I need to make sure that I am running my correct darks here. And a dark frame is something basically that takes out all of the noise from the camera. You actually create it with the camera covered, so the camera is taking exposures in complete black, so the only thing it sees is the noise generated internally by the camera. That's a dark frame, and then when you add it to all of your subframes as you come in of your regular objects, it automatically deducts all of that stuff, so what you're left with is the pure image. So the Lagoon Nebula coming along nicely here. I think I did forget to do one thing though. No, I did. Good. Alright. And this is a nebula that's about 5,000 light years away. Because it's between Scorpius and Sagittarius, it's right toward the very center of our Milky Way galaxy, where there's a lot of really cool stuff to see. We call it the summer jewel box. There's so many great things in here. Just a lot of pretty stuff. And I usually let things go for a good 10 or 12 minutes of total exposure time. 16 seconds at a time, 16 seconds, 16 seconds, 16 seconds. And the software actually keeps a running total for you, which I think you can see over here in this corner. We've so far stacked 32 frames, 32 16-second frames, for a total of 8.5 minutes. And so you know how much total time you have actually integrated. And I usually go for about 12 minutes or so, 12 to 15 usually. Tonight I'll keep it short to 12 because I do want to get the other things in before everything disappears behind the roof. So kind of running a little bit of a deadline on at least these first couple of objects. As we start heading higher up in the sky, it'll become less and less of an issue. But in fact, sometimes what I do is I bring up good old Wikipedia and just see what it has to say about the things I'm looking at. It's also called Messier 8, and the Messier list is Charles Messier was an astronomer who was a comet hunter actually, and he kept finding all these bright things in the sky that weren't comets, and so he made a catalog of what ended up being the brightest objects in the sky that weren't planets and they weren't stars, but they weren't comets. So he made a list of things to avoid, but in doing so he created a list of the 109 most spectacular things in the sky to look at. So now we all use his list kind of in the opposite way he intended. We all now look for these things because he managed to pick out some of the most beautiful things in the sky. But this is M8. This is the 8th object on his list. And it's classified as an emission nebula and as a hydrogen 2 region. It's a star-forming nebula. Cloud nebula's open cluster between 4,000 and 6,000 light years away from Earth. Spans 90 arc seconds by 40 arc seconds, which translate to minutes, an actual dimension of 110 by 50 light years across. So it's 110 light years by 50 light years across, which is a pretty long way. Like many nebulae, it appears pink in time-exposed color photos, but is gray to the eye peering through binoculars or a telescope, which is exactly why I love using my camera, because whenever I looked at these kind of things, they always were just gray, faint, fuzzy things, and I was always underwhelmed by that. And then when I started using a camera, it all changed, and I now see things the way I really would love to see them. And the nebula contains a number of Bok globules. Yeah, and the Bok globules are these dark patches in here, usually sharp, dark patches. I don't know much about what they are, but they're dark, collapsing clouds of protostellar matter. So presumably they will be stars when they finish collapsing, I guess. Okay, we're about 11.5 minutes in, so I'm going to, as soon as we get another couple of frames in, I will save this off and we'll move on to our next object, which is the Trifid Nebula, which is a pretty spectacular nebula. And I'm not going to bother to save any of this stuff, but usually I save pictures, but in this case. Alright, well, I think I will save it. What the heck. I didn't name it, but I'll save it anyway. Okay, and now we'll bring the software back in, and we'll stop our stack, and we'll go back to the 8-second, what an 8-second single exposure looks like, and now we'll reduce the exposure time so we can move to our next target, which is going to be the Trifid, which is just above. So we'll send the scope there. It's going to be just above it. Yeah, it's right down here. Okay. Let's bring you over. And bring you up a little bit. I think that's going to about do it. Oh, just a little bit higher. There we go, that'll be about right. Good. Put it back to our 16-second exposure. Put that back so we don't overexpose. And bring it in. This is the Trifid Nebula. Alright, which is kind of two parts. Well, actually, it's multiple parts, but talk about that in a minute. Okay, so let's rename this. So I name this one at least. Clear the Lagoon Nebula stack out of there, and let Trifid start coming in. Gary, yes, I do have a plate solver installed. I use Astro Tortilla. So if need be, if I can't usually find it, I usually try and take 10 or 15 seconds to try and find something, just as kind of a flashback to the old days, you know, when I was using a scope and would try and star hop to things. I still bring some of that spirit in and try and find things myself a little bit if I can. But if I don't find it, especially if I'm broadcasting, if I don't find it fairly quickly, I'll use a plate solver. And what a plate solver is basically it's a piece of software that takes a snapshot of where your scope is pointing. So uses the camera that's in the scope, takes a snapshot of where the scope is pointing, and says, oh, you are pointing here, but you really meant to be pointing here, and then automatically moves your scope and repoints it where you want it to be pointing, not where it ended up. Very powerful piece of software, and very cool for finding things if you just are stuck and can't find what you're looking for, because it's not showing up. And when you're hunting for very faint things, like the kind of things we tend to hunt for, it makes it really nice to be able to have the computer help you find it when you just can't find it on your own. So let's adjust some color and bring the histogram forward a little bit. And you can see the image right now is really still pretty noisy. A lot of noise in the background, and that's because the first few frames usually are pretty noisy, and then as more and more sub-exposures come in, the background darkens, the noise reduces, and the object itself pops forward. And so this is Trifid Nebula. Which is, this is number 20 on the Messier list. Seems to me it has all, its name actually is, it means divided into 3 lobes. And the reason for that is because these dark seams inside of it seem to divide this nebula, this brighter lower part at least, into 3 lobes. And so it was named Trifid, for its apparent 3 lobes when people started to look at it through telescopes, 300 years ago. And so it was named Trifid, meaning divided into 3 lobes. It's actually a combination of an open cluster, an emission nebula, which is the lower red portion, the part that's divided into 3 parts, and a reflection nebula, which is the upper blue portion that you can see starting to form, that we're starting to build in here with the stacking. And then a dark nebula, which is the gaps that create the 3 lobes. And so it's actually all 3 types of nebula in one nebula. And an emission nebula, if I understand it correctly, an emission nebula is ionized gas that radiates light. It actually emits light, whereas a reflection nebula is actually reflecting the light from another source, typically a central star. And so the blue one up here is reflecting the light from a central star somewhere, maybe even this star here, but I'm not sure if that's a central star inside of it or not. But it's coming in pretty nice. Hey, it's Aunt Peg and Uncle Jim. Nice to see you guys. Well, sort of see you. Tonight is going to be kind of family and friends night. I put out an email to family and friends letting them know I was doing this. Most of my family is on the East Coast, so it's pretty late for them. But looks like some of them are showing up anyway, so nice to see you guys. And let's pop the software out of the way and bring this forward a little so we can just see more of it. Coming in pretty nice. Yeah, it is. These are nice things, and as long as I can catch them before they start heading into my roof line, they usually come out pretty well. But all of a sudden, at some point, my FWHM filter, which is a filter that monitors the individual sub-exposures that come in, so because it'll automatically reject bad blurred sub-exposures if the scope happens to move or jiggle or a cloud moves over the whatever I'm looking at, and for some reason the sub-exposures start coming in bad, that filter will actually filter them out and won't let them ruin the whole stack. And so what will happen is all of a sudden that filter will start complaining, and the reason is because it's starting to get obscured by a roof. So it's not seeing anything. John and Kirsten, no, this is actually Trifid, the Trifid Nebula, Trifid, which is another nebula about 5,000 light years away, just like the Lagoon Nebula was, except this one is kind of 3 nebula in one. The red portion down on the bottom is an emission nebula, and the dark streaks running through it that divide it into 3 parts, which is why it's called Trifid, which means divided into 3 lobes, is actually dark nebula. And then the blue portion up here is actually a reflection nebula. So it's kind of a 3-in-1 nebula with all kinds of things, just in one pretty thing. And I'm assuming that the red portion is hydrogen, which is typically red, and the upper portion is probably more oxygen, which is typically blue or green when you're looking at these kind of things. So I'm assuming that's what the differences in color are. But don't hold me to that. I wouldn't bet my life on it, but I think that's right. Yeah, it's 3-in-1 in kind of more ways than one. Trifid meaning 3 lobes and 3 different kinds of nebulae, all in one asterism, all in one object, which is kind of cool. Presumably, I mean, it could be that the red part and the blue part are actually not that close to each other, and maybe we're just seeing them close, but I don't know. I think they've probably got that stuff all figured out by this point. No, Gary, I don't have a coma corrector in, which is one of the reasons why I like staying with the small 1/2-inch censored 178 cameras, because because then I can keep the optical train really pure. I don't have to have all that extra glass in there, like you would with a bigger sensor. So it's one of the reasons why I like the 178. However, with that said, and thanks in part to you, I'm blaming you for part of this, Gary, I actually went and bought a 533 today off the used market, and so I'm going to venture into the land of bigger sensors, and I actually do have an MPCC, and so I do have a coma corrector already, so I don't know, we'll see how it goes. But yeah, I am. I have stayed with smaller sensors, in part because I didn't want to deal with a coma corrector. But now I'm gonna jump in, and we'll see how it goes. Definitely have seen some nice things out of that 533, including some really nice stuff you've been putting out in your in your streams, and 533 looks like a really nice camera, but it is a big gulp paying that much for a camera when it costs more than my mount and scope combined for just the camera, but oh well, we'll see. Speaking of which, let's see how our histogram is doing here. Yeah, we're looking pretty good there. Could possibly push this stretch a little bit more. See how our color is doing. Always tends to put a little too much blue, but I think that's coming along pretty nice. Let's see. Alright, well that's looking pretty good, so we're going to save that as is. So that's looking pretty nice. And there's our Trifid Nebula. Okay, turn off the stacking and... Oh, you can't turn it off that way, you got to bring the software back. There you go. Now we'll stop the stacking and bring our exposure down. And I want to recenter this a little bit because we're kind of off just a little bit there. I want to kind of recenter that a little bit better. Yeah, let's bring our... Yep, okay. I think that's about right. No, wrong way. Wrong way. Wrong way. I think we might be doing a star cluster next. We have some more bright clusters to bright nebula, excuse me, to look at in a bit, but next on the list, going south to north in our sky again to keep the roof at bay. What am I doing? I don't know. We're going to go, I think, to a cluster next. Okay. So we will synchronize our mount on the Trifid Nebula. Back out a little bit here. And yeah, I wanted to take a quick look at M22. That's a nice cluster. So we'll do a star cluster next. Get rid of these crosshairs because I've already aligned. This will probably show up pretty readily. Yep, there it is right there. So let's bring it down a little bit more into our frame. And I can actually control, you see I'm actually controlling the scope from this software. Again, this SharpCap software that is wonderfully powerful stuff. And I can control my scope from inside it, and I control my camera settings inside it. So up here I can actually move the scope in whatever direction I want to bring it into my view a little bit better. And then down here are all the camera controls where I get to control the exposure time. In this case, I'm going to go to about 8 seconds. Clusters, globular clusters, star clusters tend to be much brighter than the nebula that we've been going after. So if you go more than, so I tend to keep the exposures lower. Otherwise it tends to blow out. And then I need to get my dark frame set for the correct thing there. Okay, and now let's start stacking on this. Oh, but before I do that, I gotta go 22. And then we'll clear out Trifid, reset our histogram, and let M22 come in for a little bit here. So this is a pretty bright globular star cluster. See what Wikipedia has to say about it. It's an elliptical globular cluster of stars in Sagittarius, yeah. It's near the galactic bulge region, so again, this is where our kind of near, right in the direction of the center of our Milky Way. One of the brightest globs visible. The brightest stars are 11th magnitude. M22 is located just south of the ecliptic and northwest of Lambda Sagittarii. Sagittarius being the teapot in our sky. It was discovered in 1665. Man, it's pretty bright. So somebody found it pretty early. It's one of the first clusters to be carefully studied, and it was discovered roughly by a man named Harlow Shapley, and he discovered 70,000 stars. I don't know how the heck he counted all that, but one of the nearer globs to Earth at a distance of about 10,600 light years away. And it has a diameter of about 100 light years across. Alright, let's bring a little more of this in. Let's bring some color in. That's going to put way too much blue. You can see it's quite a spectacular mess of stars in there. Oh, this actually contains a planetary nebula. Huh. And at least 2 black holes are also inside it. Interesting. Planetary nebula is a star that's basically starting to die. and it's blowing off a lot of its gases, but it's still glowing. So it's the star that's at the core of the explosion is still illuminating all of the gas that it's exploding outward into space. So it creates this large glowing orb that initially were thought to be planets. That's why they're called planetary nebulae, even though they have nothing to do with planets. They're actually stars in part of their life or death process. And so they're pretty cool. And actually tonight, later on, we will probably take a look at one or two of them, because there are a couple of really nice ones in the night sky right now. One of them is called the Dumbbell Nebula, and the other one is called the Ring Nebula. And both of them are up in nice places to see them tonight, so we probably will take a look at those later on, after we get out of the southern sky here on these things. Yeah, thanks, Gary. It's for a simple, inexpensive little Newtonian telescope. They really do great. They're a simple design and just really effective. And if you're doing imagery, these fast focal ratio Newtonian telescopes they do great with cameras. Is what they're built for, and that's really what they're great at. And they're relatively cheap compared to similar refractors and the like. Hey, good evening, Edie. Nice to see you. Right now we're looking at Messier 22, which is a globular cluster of stars, which apparently they did an intense study of in like 1930 and found at least 70,000 stars, I think they said. So it's quite a compact and bright globular cluster, and in fact I think there's a lot of dust between us and it, so its light actually a lot of its light is getting dimmed down, so it's actually probably a lot brighter than what we see. No, Edie, you the only person who can actually be heard is me. There's no vocal chat on YouTube live streams, so you just you type to talk to me, and I talk to you. So yeah, Gary, SCTs are also great scopes. SCTs are the wonderful thing about them, other than there being nice compact sizes, is that they are extremely versatile. So they can be used at really low focal ratios, and they can be used at really high focal ratios for doing planetary work. If I try to do planetary work with my imaging newt, it doesn't really work so well. The focal ratio is too low, the focal length is too short, and even with I basically have to go to a really aggressive Barlow to be able to pull them in even any decently at all, and it doesn't really do a good job. So the nice thing about the SCT, kind of a jack of all trades, master of none, is that it can do all those things pretty well. It can do the faint fuzzies at fast focal ratios, it can do planetary stuff and solar system stuff at slow, long focal ratios. They're extremely versatile. Which is why I tend to stay away from doing a lot of solar system based stuff, because my little newt doesn't do very good, and I prefer the DSO, the deep sky stuff anyway, so it's where I kind of hang. Yeah, getting some nice resolution on some of those stars. Another good thing about, see if I can stretch it a little more. Another good thing about the This 178 camera doesn't have spectacular sensitivity, but it has really good resolution, and I like that a lot. But we don't have to do so much time on the globs. These brighter globular clusters they don't need to take a whole lot of time. If you spend too much time on them, they just start blowing out and getting overexposed if you stack too much. Hey Kenton, good to see you on, buddy. We're just looking at M22, a globular cluster. It's by Sagittarius, and just finishing stacking some frames on that. It's looking pretty good so far. Kind of back off a little bit and get to see it more in its native environment. It's in a pretty rich star field, being again toward the Sagittarius-Scorpius direction, which is the center of our Milky Way, so there's almost always a lot of stars in the background. It's a real star-rich place. And excuse me. And so good. Okay. Pretty star-rich location, so I think I'm going to save this, and we're pretty. That's pretty well cooked, I think, for where we are. And then we will stop that stack and make sure we're pretty well aligned on it. I think we are. Go back to our planetarium and let's go up to that one's a little faint. We could try going into the Sag star cloud a little bit. That's this puff of clouds up here, which is a Sagittarius star cloud, which is an extremely rich place. Lots of stars. We can try stacking on that for a couple of minutes. We've got a little time. And let's see what we can see up here. This will just mostly be a rich star field in the background. Yeah, you can kind of see the hole here, or the dark spot. So we'll Sag star cloud. And we'll start stacking on that. We'll clear M22 out. And we'll just kind of leave that set like that for the moment. Probably come in pretty noisy at first, but it'll clean up as we pull more and more frames in. Gary, yes. I usually run at really high gains. I'm not sure why, but in every camera I've ever owned, from the first 224 I owned to the 305 to the 178s, no matter what cameras that I've owned, if I run at less than max gain, I just don't see anything. I don't know if that's because I'm doing something wrong or I don't know what, but it always just works better for me to work at max gain. It means I do get more noise, and it's more grainy. Takes longer for the stacking to smooth things out, but it really is the best way for me to actually be able to see stuff, and It's just, yeah, I noticed you're running pretty high as well. I always hear people who talk about, yeah, you should run at, 250 to 300 or 350 at the max. I try I try playing in those arenas, and I can't see anything. It takes way too long an exposure to pull it in decently without a much higher gain. So I just stick to the higher stuff, and it seems to work okay for me. Like I said, it's a little noisy sometimes, but I'm okay with that. But here, basically what you can see is a gap, kind of this hole right in here, which is this, kind of this gap that we're seeing in here. Probably this one here, might be this one, but I think it's this one down here that we're seeing. It's just kind of a gap in the star cloud, and what you're actually seeing here is a gap in the dark dust that is between us and the center of our Milky Way galaxy. Sagittarius here, Scorpius here. We're looking right at the center of our Milky Way galaxy in here, which is big and bright, but it's mostly obscured by dust and dirt and kind of crap in the way. And there's only a few holes where we can kind of poke through and see some of what's going on there, and the Sagittarius star cloud is one of those places. And so that's kind of what we're looking at right now, is sort of a hole in all the dust and stuff that's between us. Let me full screen this and get this out of the way. Kind of a gap in the dust and things that allow us to see what's going on more toward the center of our Milky Way. And these dark patches are where there's just a chunk of dust sitting in there, blocking more of that central region from us. Edie, yes, noisy in this case means a lot of speckling, basically a lot of white pixels. When you pull up an image with a dark background and it has a lot of pixels in it, that is what I mean by noise. So in this case, it's visual noise. When I move to the next object and start stacking a new stack on the next object, you'll see what I mean. When the way this software works is it takes 16-second exposures and of what I'm looking at, and it stacks them. It takes a 16-second exposure and then takes another one and uses the background stars and aligns the two sub-exposures and stacks them on top of each other. Basically adds them together. And then takes another 16-second, aligns them using the background stars, stacks it together. So it's continuing to just stack and stack and stack 16-second exposures of what I'm looking at. And as more and more of the first ones come in, they're really noisy. And as more and more stacks and more sub-exposures come in, the background gets darker, the noise smooths out, and whatever objects I'm looking at tend to get brighter. In this case, I'm just looking at stars, the Sagittarius star cloud, so there's not a whole lot of bright stuff in there. But when we move on to the next object, which will be the Omega Nebula, you'll see what I mean. When the first frames come in, it'll be really noisy in the background. It'll be really bright and speckled with a lot of white pixels and white noise. And then as more and more subs come in, the background will get darker, the noise will smooth out and disappear, and the object will get brighter. So, like Gary said, this is probably a dark nebula, or some sort of dust, dirt, something between us and the center of the Milky Way that's just blocking our view of the stars that are behind here. And the few stars that we see inside here are most likely stars that are between us and that dark nebula or dark matter. Well, not dark matter, but because that's a whole other situation. But the dust or whatever that's between us and it. Yeah, sure, Edie. Let me know if you have any other questions. Happy to answer what I can. And if I can't answer it, I got Wikipedia right here. Hopefully it can. But as we sit here and stack more, you can see more and more stars coming in. And you can see probably see the different colors. Some of them are blue, some of them are more red, or yellow, orange. It's a red star here, a small red one. All the different colors of the different chemistries of the stars, the different sizes, how hot they burn. Push this stretch a bit more, see if we can get a little more out of this. I found that I can push the stretch a lot more on my screen. Yeah, that's another thing too, Gary, is the bluer they are, generally speaking, the younger they are. The blue stars tend to be the ones burning the candle at both ends. They tend to not live quite as long because they burn themselves out faster, but while they're alive, they burn hot. Yeah, so we just have this nice dark patch here. It's probably a dark nebula between us and that starry background. But lots of stars in there. Lots of stars, not the background stars in that in the star field. But let's go ahead and take a picture of that. And we will move on to our next object, which is going to be the Omega Nebula. Alright. Omega Nebula, which is not too far away. Again, we got to make sure we can get these things before they get hidden by my roof. What are we doing here? Okay, yeah, so it's up above that. So, yeah, we're still okay on this. So, let's see where we are here. Probably pretty close to it. Yeah, there it is right there. Okay. Let's center it up a little bit better. Bring it down here a little bit more. Alright. And then stretch out to 16 seconds and see what we can get for this. So, see what we can pull in here. And I've actually had some people show up here in person, so if you hear a voice in the background, it's Sarah and Jim. Hi guys. Okay, so we've got that kind of centered in there. We've got the exposure turned on, so now let's start the stack on this. And this is going to be the Omega Nebula. We'll clear out the old one. And we'll start stacking that in. So there, Edie, like I was telling you earlier, there is the background you can see is really noisy. It's got a lot of speckles, a lot of white stuff in there, and that's all basically noise from the camera. And as more and more subframes come in and get stacked on top and added in to the image that's already there, oop, time for some food. As it gets added in, all of that will get smoothed out, and that will disappear in time. It basically, the stacking process makes the dark stuff darker and the light stuff lighter. And so over time, as I bring in more and more sub-exposures, and you can see down here on this little meter down here in the bottom right corner, this is the individual exposures coming in. So that takes 16 seconds to get to the end, and then it starts all over again. It takes another 16-second exposure, and it stacks it on and stacks it on, and continues to improve the image as it goes along. And it's kind of a poor man's astrophotography. Traditional astrophotography is where you put your telescope on something, and it has to be a telescope that's on a really good mount that tracks very carefully, because what you're going to do is you're going to open the shutter on that camera and you're going to take a really long exposure of sometimes minutes, sometimes even hours of an open shutter to collect enough light to really get a bright image. And to do that, obviously, takes an extremely heavy, large, expensive tracking mount to move your telescope so incredibly precisely that all of your stars stay nice and round, and you don't smear and smudge things and turn your stars into streaks. So it has to be able to do a really good job tracking. To be able to do that, and that's traditional astrophotography. Well, what's happened in the last number of years, several years I suppose, is what's called stacking, and it allows you to take much shorter exposures using software and using, again, the background stars to align each subsequent frame, stack it on top of the stack that's already there, and keep stacking and stacking and stacking. And because you're only taking really short exposures, relatively inexpensive mounts can be used. Your telescope doesn't have to have as precise a tracking to keep it well enough on target to keep things from getting a mess, but yet you're getting to add them up and add them up and add them up, and the total integration time still can come out to be minutes or hours or however much you want. You kind of end up with sort of the same thing, but it just requires much less rigorous equipment, much less expensive, and it's honestly, it's a whole lot more fun watching something that changes every 10 or 15 seconds than having to sit by your telescope and wait 5 minutes for an individual frame to come in. So it's just a lot more fun too. Yeah. Thanks for coming by. Hey, good night, Gary. Probably already missed you, but yeah, have a good night. I'll see you on cloudy nights. Curtis, this is the Omega Nebula, which is right above and between Sagittarius and Scorpius, kind of right above Sag. Yeah, it is still it's still pretty nice. Let me, in fact, make it look even better by getting the software out of the way. Kind of bringing it in so you can see it a little better as it stacks in. Yeah, even with the noise, it's pretty nice. But over time, with more stacks, it will, as more and more images get stacked on top of it, the noise goes away, and it just continues to look better and better. you can see at the top kind of how it's kind of light and fuzzy at the top, right along the top border of the image, and that's amp glow from my camera. That's just the nature of an electronic sensor, is that it can generate its own noise, its own stuff, and so that's kind of the amp glow that it's. Oh, and I know why it's causing that too. Ha! Because I have the wrong dark in here. That's why. Boom. Yeah, I got the wrong dark going in there. In fact, I'm going to clear this and restart, because it'll look a whole lot better with the right darks in. So we're going to start over again with the noise, but it'll reduce a lot of that stuff at the top, or at least it should, because that amp glow is part of what the camera produces, and that's part of what the dark frames help to subtract. And I just forgot to put the correct one back in there. When I went to 8 seconds for the globular star cluster, I changed to the 8-second dark because the darks are different for the different exposure times. And when I came back to 16 seconds to do the Omega Nebula here, I forgot to put the dark back to the 16-second dark. So we're starting over again. But I think it'll be worth it. Going and finding Mars. Hey everyone, it's my mom. Hi Mom. Looked up on Wikipedia, it's also called the Swan Nebula. Yes, Edie, that's true. It is also called the Swan Nebula. Why so many names? Well, good question. It was probably there. Astronomy is a worldwide hobby, so different people in different parts of the world called it something different. They looked at it just like looking at clouds and seeing different shapes and different animals in the clouds, depending on who you are. They looked and saw different shapes and decided to call it something different, and all their friends started calling it something different, and then, so now in different parts of the world it was called different things, and then we all get together and on the internet and go, wait, no, it's called this, no, it's called this. How about we just have all kinds of different names for it? So, I don't know, that's a guess, but I'm thinking it just has a bunch of different names because there were a bunch of different people who discovered it way back when and didn't know other people were discovering it and calling it something different. While this stacks in, I think I'll take a break for a minute. I'll be right back. I'll let you guys watch this come in. Okay. Well, that was kind of fun. Had friends actually stop by to see what I was looking at tonight. Okay. Okay, good night, Aunt Peg. See you later. Sleep well. Now that you got your stars in your eyes, you can sleep well. Yeah, as you can see, we still got some of that light band at the top. That's the result of the amp glow, but I think it looks quite a bit better than it did last time. Let's see how our histogram is doing here. Yeah, we got a little, it's a little bit off. That will help. That will help some there. Let's see what we can see for this. Adjust the colors a little bit. Is this an emission nebula? Trying to remember if this is emission. I think it's an emission nebula. Swan, checkmark, horseshoe. It's a hydrogen region. It's between 5,000 and 6,000 light years away. It spans 15 light years in diameter. The cloud of interstellar matter, which is the nebula is part of, is roughly 40 light years in diameter and has a mass of 30,000 solar masses. The cloud of interstellar matter of which this nebula is a part is roughly 40 light years in diameter. Total mass of the Omega Nebula is 800 solar masses. It is considered one of the brightest and most massive star-forming regions of our galaxy. Its local geometry is similar to the Orion Nebula, except that it's viewed edge-on rather than face-on. Oh, that's interesting. I didn't realize that. The Orion Nebula, you can see, is splayed out like a large bird or something, and this one is much smaller because we're seeing it basically edge-on. Huh. Not really seeing whether it says it's an emission or a reflection nebula. Oh well, if anybody knows, put it in the chat. Edie, well, I actually just started doing it. This is only the second one I've ever done. I did one a couple of nights ago on let's see, heck, I don't even know what is this? Is this Wednesday? Yeah, so I did one on Monday night. That was my first YouTube stream on Monday night, and because I didn't really know what I was doing, I did it for a smaller audience. Gary was actually there. He's not here now, but Gary was actually here for that, and just to kind of figure out what to do. And as it is, even at the end of that, I had some technical problems with some things. So how often am I doing? I'm going to start doing it more and more. Basically, if the moon is in its dark cycle, so a couple of weeks out of the month, basically between the new moon and the full moon, or excuse me, the full moon and the new moon, that period of time right there between the full and the new moon, when the moon is typically darkest, is when I'll be doing this fairly frequently, probably almost any good weather night that I can, when there's not a storm happening here and there's not much clouds. I'll be doing this. So, but I will, I will be letting people know. I'll be sending out emails like I did tonight, or, you know, letting people know on cloudy nights, which is an astronomy forum that I frequent, and letting folks know that I'm doing it. I also will start advertising it on the Las Vegas Astronomical Society Facebook page, and so that I'll have more of my local club folks here. I didn't have them here tonight because I wasn't sure how many people were going to show up. So I basically, tonight I kept it to family and friends and that kind of thing. But I'm going to start doing it fairly frequently whenever the moon is in its dark phase. Like I said, a few days after full moon until a few days after new moon is generally when it's good to do astronomy. The other 2 weeks there's usually a lot of moon in the sky, and so it's not as ideal. Yeah, the Santa Cruz had a great astronomical group. I really liked when I lived there, being a part of that. It's a pretty active group that has regular gatherings and outreach to schools and things, a lot like the Las Vegas group does here. But I don't really have a way of contacting them. And, well, they must have a Facebook page, but I'm not sure any of them would even remember me now. I've been away for so long. But yeah, it's I'm really enjoying using the camera. It really has awakened astronomy for me again. I can finally see things the way that I've always wanted to see them. When you look through the eyepiece of a telescope, even a pretty big telescope, you're really, really lucky to see any color at all. And something like this would be, a very faint, wispy thing, but it would, it wouldn't show very much color. But with the cameras, number one, are much more sensitive than the human eye. So even just one subframe sees much more than you could see through an eyepiece. But then when you go to add the stacking, that's just another whole thing. And yeah, Edie, I did send Andy an email. He is part of the email group that I send out to. So who knows? He may be here. Yeah, like I said, he should have received an email just like you did. So I'm sure if he could be here, he would be. But yeah, if you ever see him, let him know I'm doing it. Maybe there's some reason he's not getting my emails, but yeah, I'm sure he'd love to, and I'd love to have him here. He's another astro nut like me. Let's see, well, we've already gone over 12 minutes, so I think we're going to save this as is. And bring our software back and stop the stack and reduce back down, and let's make sure we're still on it, though. Before doing that, I should have made sure we're still close. I need to make sure that we're still good. We still have it centered in the camera here. Yeah, shoot. Supposed to do that. Okay, yeah, it is a little bit low. Alright. But it's okay. I'll go up a little bit. That's probably about right. Okay, and now we will go to Eagle, which is just above it. Just above it, right there. Send the scope up to there. And aggressively stretch here, see if we can't see it. Yeah, so it's going to be this stuff in here. Yeah. Boom, boom, boom. Yeah, so we're pretty much right on it. So let me put our stretch back and go back out to our 16 seconds. And that should allow that to start coming in. Nice to be able to see this summer stuff one last time. And let's see. Eagle Nebula. Alright, clear out Omega. Reset the stack. Let's see what we can see. Just set this to 10. I think that's good enough. Yeah, there it is. Just real faint at the moment. Starts off real faint and noisy, but over time it will come in. So it's going to be right up in here, you can see it. This one we can usually, this one I actually usually sit on for longer than 12 minutes. It does take a little time to come in, it's pretty faint. What is it? It's yeah, it's a surface brightness of 14.4, 14 and a half. So and you know what? I'm going to start this stack over again because I think our first frame came in with not round stars. Well, even that looks smudged. Okay, try it again. See if we can't get a good start. Huh. You know what? I am wondering. I think what might be happening here is I might be in my roof. I think which is why the bottom half of this is there's nothing in the bottom half of this and it's blurred and smudged because I'm actually half of it is getting cut off by my roof. So yeah, we're not going to get to see this one. We're not going to get to see this one because it's already set so low into my roof that it's just not going to happen. So let me pick something else that's up a bit higher here. Let me make sure that I've got my things. No. Huh. How does this stuff keep getting reset? I keep adding these things and it keeps deleting. Okay, open clusters. Yep. And we're going to bring this. And we'll bring it down some. Okay. There. Now we can see there's more things in here to see. Including M11, the wild duck cluster. Let's go to another. This is an open cluster now. Not like a globular cluster, like what we saw. Gotta turn this stuff off. Reduce this back down. Yeah, you can see this cluster in here. This one, unlike M22 that we were on earlier, this one will be fainter and looser. It won't be such a bright, intense cluster of stars. It'll be a much looser accumulation of them. And that's probably about right. Synchronize that. And let's go out to 8 seconds. I think 16 again for 16 will be a bit much for stars, usually is. Looks like the scope is moving a little bit still too, so we'll let that settle out. Sometimes the scope needs to just settle a little bit for a minute. There we go, that looks about right. Alright, and let's adjust our, now that we've changed to 8 seconds, let's get our correct dark in place. And this is N11. And we'll clear that out. So glad you're getting back into this. Somebody named My Zinfandel. I wonder who that could be. Hi Zinfandel. How's B? And yes, I'm enjoying getting back into it myself. It's astronomy has been something I've enjoyed my whole life, since my parents bought me my first little cheap Sears refractor when I was a teenager. I've really enjoyed astronomy, and it became an off and on kind of thing. Mostly I went off it because when I looked through the eyepiece, what I saw was just faint and gray and fuzzy and kind of lacked the wow that I really wanted to to see when I looked through it. I mean, I wasn't expecting to see the Hubble images, or the stuff I saw in magazines, but at least I wanted to, see a little bit of color or something. And everything was just so small and faint every time I looked through the telescope. And even later in life, when I bought bigger telescopes, faint gray fuzzies were still mostly faint gray fuzzies. And it wasn't until I started using a camera that the world opened up for me, and I could really see a lot more colorful things, and really see things the way I wanted to see them. And so, cameras, I've been using cameras now for a couple of years, and it's just really been wonderful. And now that we're in this crazy pandemic world that we're in, and real traditional star parties inappropriate, this is now a great way to share this kind of thing with others, and have virtual star parties and share the wonders of the night sky with people locally and far away. So I'm really enjoying it, and really glad that I started down this road and am now branching out into broadcasting, live streaming what I'm looking at. So yeah, Curtis, I think EAA, which stands for Electronically Assisted Astronomy, or the use of a camera or some sort of photosensitive device to see your objects rather than use your eye in an eyepiece. It's truly been a marvelous thing. I love it, and the cameras keep getting better and better and better, and we'll just be able to see more and more and more as that happens. The lines continue to be blurred between EAA and true astrophotography and what the pros do. I mean, the things we can see today with our cameras designed for the consumer rival what the professionals were seeing 10, 15 years ago. And so it's just amazing what we can do now from our own backyards without having to spend a fortune. I mean, it doesn't take expensive stuff to do this. So, you know, it's a lot of fun. Oh, did Erica show up too? I thought it was just Zen and B. I would assume that it was. I don't know. Maybe they dragged Erica along too. But it's good to see you, Zen. Haven't seen you in a couple of months since you were out here last. Alright, so we're on M11, the Wild Duck Cluster, which, according to Wikipedia, was so named because the cluster resembled sort of a wedge shape, which was kind of like a flock of geese flying, through the sky. So it was called the Wild Duck Cluster. Although what I don't remember is how far away it is. Hello, Wikipedia. Wild, no, not Sild. Wild Duck Cluster. Wild Duck Cluster, open cluster in the constellation of Scutum, the Shield. Discovered by Gottfried Kirch in 1681. And Messier included in his catalog. There's M11. Its popular name derives from the brighter stars forming a triangle which could resemble a flying flock of ducks. Or from other angles, a single swimming duck. Most massive open. It's one of the most massive open clusters known. It's estimated to be 316 million years old. Let's see, does it say how far away it is? Huh. Doesn't seem to mention how far away it is. Oh well. Well, doesn't really say. Oh well. Probably just do a couple of more minutes on this. Good night, Edie. Thanks for stopping by. And you can always look at this, these live streams, of course, turn into just regular YouTube videos afterwards. So you can always come back and see the rest of whatever we saw tomorrow or the next day or next week, whatever, and see the rest of it. So anyway, good night. Thanks for stopping by. Good night, Edie. Okay, gotta plug in my other laptop. No, Curtis, I'll be here for a little bit yet. Got a few more things I wanted to look at. So I'm not signing off quite yet. Just my friend Edie was going, that's all. So I was saying goodnight to her. Okay, well, this is coming in pretty well. I don't know what we can look at next here while that finishes up. Here's where is this east? What? No, that's not. No. Let's see where it has. Yeah, East and West Vale. Yeah, these are interesting to look at, but they're so faint that I think I will leave them for now. Those are much better with the 533 than they will be with this particular camera. There's always the Ring Nebula. That's a great thing to look at. We'll definitely look at that tonight. Yeah, some of this other stuff. Flying Unicorn Cluster. There's a lot of open star clusters that are really great to Tweedledum cluster or the Captain Hook cluster. Well, that's just so interesting a name. I think we're going to have to go look at that. Oop. Ah. I'm trying to select the cluster, not the... It's not going to let me, huh? Okay. I think we've got about all we can get out of this. So we're gonna put that away, stop our live stack. And make sure we haven't drifted too far out. No, we're still pretty good. And let's try going over to this one here. Send the scope over there. We'll see what that cluster has to show us. Yeah, it's a pretty loose open one. That's what it's looking like here. It's definitely a much bigger kind of thing. And we'll see what it can see on it. What was it called again? The Tweedledum cluster, or the Captain Hook cluster, or Wasp Waist cluster. Okay. NGC 6633. Clear out the wild duck cluster. And see what this little cluster, big cluster I guess, brings in. If there's anything interesting in there. Ultimately, I think I'm going to get back into my galaxy hunting, but that requires my mono camera. Color cameras don't do quite so well with galaxies. The mono cameras really excel at them. Tweedledum, huh? I don't know about that. I think next we'll just go to Ring. Take a look at the Ring Nebula. And M56. Yeah, we'll take a look at the Ring Nebula next, and M56. Ring Nebula is a pretty good one to look at. It's a planetary nebula, one of the brighter planetary nebulas in the sky. And it's fun to look at. Yeah, I don't know that this is going to turn into a whole lot more than just what's here. So, I think we'll just save this out and move on to the Ring Nebula. I don't think there's going to be a whole lot to see here that we're not already seeing. Yeah. Okay. We'll turn off our stack. And we'll jump back down to there, and we will head over to the Ring Nebula, which is going to be right up here. And usually just, and there it is, right up there. Big as day. Bring him down into the picture a little bit. fact, I'm going to center it up and resync the planetarium. Right into the center as much as I can. You'll call that pretty good. Over here, sink that in. And start doing some stacking on this. Now, like the star clusters, again with the Ring Nebula, 8 seconds. If I do more than 8, it tends to just blow it out. And this way, it doesn't. You can kind of see it real nice. So, alright, let's start oh, I know what I wanted to do. No, I need to name it first, though, don't I? Yes, I do. Ring Nebula. And we're going to start stacking. Clear the old. And bring in the new. And let it get a few frames stacked on there. And we will and so anyway, this is a planetary nebula, which, as I said earlier, has nothing to do with planets. When they were first discovered, they looked like orbs. Obviously, they weren't stars. They weren't points of light. It was obviously a sphere. And and they did have some color to them, so they thought originally they were planets. And later it was discovered that they were nebula, and so they were just called planetary nebula. But they actually have nothing to do with planets. They're actually stars in typically a later part of their life process, where they are beginning to expel large amounts of their material, gas and their material, ionized matter and whatnot, expelling it outward from their core. But they haven't burned out yet. They haven't burned themselves out. So they, the core star, the star at the middle, continues to shine and illuminate the gas that it's actually blowing out into space. And so that's what's happening here. And you can actually see, as we continue to stack in here, you can actually see the point of light at the very center that is the star that's actually creating, has created and is creating the planetary nebula that's in there. And so this one is called the Ring Nebula. And it's a pretty bright, shiny object. Now that we've got a few frames in, we can adjust the stretch a little bit more, adjust some colors, so it's a little bit more realistic a color. Might have overstretched it a little bit there. And we'll let it continue to come in. It's very small, obviously, but small but intense. Thanks, Curtis. Yeah, it's a pretty Pretty cool little object to view. It's tiny though. You try looking at it through a telescope and it takes some magnification to really see it. It's a tiny little sucker, but pretty bright. Let's see if Wikipedia has anything interesting to say about it. Planetary nebulas are formed when a shell of ionized gas is expelled into the surrounding interstellar medium, aka space, by a star in the last stages of its evolution before becoming a white dwarf. This was discovered by Charles Messier in 1779. Evidently discovered the nebula while following the comet. It was also discovered by French astronomer Antoine Darquier de Pellepoix 2 weeks later, who then independently rediscovered the nebula while following the comet. Pyrgo. Darquier later reported that it was as large as Jupiter and resembles a planet which is fading, which may have contributed to the use of the planetary nebula terminology. It would be entered into Messier's catalog as the 57th object. Messier and William Herschel speculated the nebula was formed by multiple faint stars that were unresolvable with his telescope. How far away it is? Does it say? Central star of magnitude 14.8 is difficult to spot. Yeah, unless you got a camera, I suppose. Well, I don't see. M57 is an example of the class of planetary nebula known as bipolar nebulae, whose thick equatorial rings visibly extend the structure through its main axis of symmetry. It appears to be a prolate spheroid with strong concentrations of material along its equator. From Earth, the symmetrical axis is viewed at about 30 degrees, so we're almost looking at the very top of it, but it's off by about 30 degrees to us. Fireworks galaxy. Yeah, it seems to me I have imaged that with my mono camera. I think it's too faint for me to be able to see it with this camera, but we could try. If it's up, we could try. If it's in a good spot to view. Let's see where it is here. Where are we at? 340. Yes, okay, so northeastern sky. Yeah, we might be able to see it. Surface brightness of mag 14.5. Yeah, that's probably, that will be a great target for my mono camera. With the color camera, I doubt I'll be able to pull it in very well. But we'll give it a try anyway. What the heck? A bit later on, we'll give it a try. Okay, why am I watching that? We're supposed to be watching this. And we're at almost 10 minutes. I think it's doing pretty well. It's a little bit blown out. But I think that's probably going to be about as good as we're going to get with this. All right. What I wanted to do next, well, let's go ahead and see if we can do fireworks. Why not? I want to do dumbbell also, but we'll see if we can pick up fireworks with this. I'm not real hopeful, but we'll give it a shot. It's a little bit faint for this color camera. But we'll see if we can pick it up. Don't see it yet. Still don't see it. Oh, there it is right there. Okay. There it is right there. Okay, so it's right in here. So let's bring that up and into the middle of the screen a little bit better. Yeah. Okay, that's probably about good. All right. We'll definitely need full, I'll unstretch that. We will definitely need to have the full 16-second exposure for this one. So let's get the right dark on that. Let's see if we can pull it in. Oof. Well, I don't see it at all now. Hopefully I didn't move it too far out. No, it's right there. It's right there. Okay, well, let's start stacking. Fireworks. No. Fingers in wrong places. Fireworks galaxy. Okay. Clear that. We'll just see what we can see. Yeah, there it is right there. This is going to take a few minutes to see if we can stack it in. We'll give it a shot. It's right in there. I don't know that I'm going to be able to get a whole lot of it, but we'll see. Yeah, I'm going to probably in the next my next stream here, probably the next day or two, is going to be I'm going to switch to the mono camera. I've been playing with the color now for a couple of weeks, and I'm about ready to do some galaxy hunting with the mono again. So. We're going to have to stretch the heck out of this to see it. It's definitely there, though. Stretch it till it's noisy. Do a color on it. Pull the blue back. Oop. Wrong button. Yeah, we'll have to see how this does. And actually, while it's stacking here for a couple of minutes, I'm going to go. The little bit of a breeze has picked up and it's gotten pretty cool, so I'm going to go quickly change in to throw some sweats on over my shorts and t-shirt. And so I'll let this stack here while I'm gone. Be right back. All right, warmer now. Definitely there. Really having to stretch it very aggressively to see it, which is resulting in a noisy image, but it's there. The mono camera would definitely pick this up a lot better. One of the reasons why I love my mono camera. Got some little weird red artifact here on the screen. Not sure what that's about. Walking noise perhaps from the camera. A hot pixel gun, streaky, I'm not sure. Well, it is coming in. It's faint, but I am able to pick it up. Having to stretch it very aggressively to do so, but it is coming in. Yeah, I think it's yeah, the mono will definitely do well on this, but not bad for color. These 178s are really designed to be planetary cameras, so I'm not really using it for its intended purpose by trying to pick up DSOs, especially faint ones. This camera really, to pick up faint stuff, really wants to have really long exposures that I can't do on my AltAz mount. But today I went and splurged and bought myself a 533 off the used market, so that should provide a whole lot more sensitivity for things like this. I'll have to see how that works. See if I like that. That one will probably pick this up nicely, but for now, my Galaxy Hunter is my mono camera. I really love using my 178 mono. Lots of detail and really good sensitivity for galaxies. But this one isn't doing too bad. Good night, Kirsten and John. Enjoy your dinner. I'll see you guys soon. The camera that I just bought, Curtis, is it's a ZWO ASI 533 Pro, which is the newest, latest, greatest bleeding edge technology sensor to hit the market. And it's getting rave reviews. So I got somebody was selling one on the Cloudy Nights forums in the classifieds today, and I picked it up, and we'll see. But it's a super sensitive camera. It does not have any amp glow, unlike the amp glow that you can see in my images here, especially along the edges, along the top, where it's all white. It's all amp glow that's up there. And it has no amp glow and very low noise and really good sensitivity. So we'll see. Alright, we'll do a couple more frames on this, but I think we've gotten, in my experience, that 12 minutes is about all I can, it's about the most bang for the buck. If you hold on, you can get a little more, but it's usually not worth the time spent, because the difference is from about beyond 12 minutes or 14 minutes or so on are pretty incremental. But I think it did all right for a pretty insensitive color camera designed for planetary work. I think it did pretty good on this. Alright, I think we'll just save that up and move on to what I think will be the last object for the evening, which will be the Dumbbell Nebula, which is another nice bright planetary nebula that my camera usually responds really well to. So let's go do that. Let's put this back in. We'll make sure we were back in the center here. About to go do a big move. Let's make sure we are not too bad. Okay, so it's right about there. centered you on it. And now let's go to M27. Although, Iris, I did Iris the other night. It came out okay. Cave. 8 and it's 9 and 12. 7 and 11. Yeah, cave was too dim. Swimming alligator cluster. Whoa. Yeah, I think I have one more in me for tonight. And that is going to be M27. So let's go find our dumbbell nebula. Whoop, come on, you. Yeah, there you are. Okay. Let's go over there and see our dumbbell. Well, there she is right there. Okay, move you down into the frame a little better. In fact, I'll just square you right up. And bring you over there. That's probably about right. Increase exposure, set that back, get rid of our reticle. And start. This is going to be dumbbell nebula. Okay, start on that. Clear the fireworks out. Reset this histogram. And let a few subs come in on the dumbbell. Then we'll play around with the histogram and bring it in better after it's collected some data. And let's see what the Histogram has to offer here. Bring it in a little more aggressively. And do a little bit of a color balance. Starting to show some nice detail. See what a wiki has to say about it. Oh, there is two B's in dumbbell. Oh well. Dumbbell or apple core nebula. It's about 1,200 light years away. Oh, that's not too far at all. It was the first planetary nebula to be discovered by Charles Messier in 1764. Easily visible in binoculars and a popular observing target in amateur telescopes. The Dumbbell Nebula appears to be shaped like a prolate spheroid, which is also what we just heard about the Ring Nebula, and is viewed from our perspective along the plane of its equator. So we pretty much see it dead from the top. In 1992, Morena Corral et al. Computed that its rate of expansion in the plane of the sky was no more than 2.3 arcseconds per century. From this, an upper limit to the age of 14,600 years may be determined. 1970, Bukowski, Smith, and Weidman found an expansion velocity of 31 kilometers per second. Given its semi-minor axis radius of a little over a light year, this implies the kinematic age of the nebula is some 9,800 years. So somewhere between 10 and 15,000 years old, they're not sure. Like many nearby planetary nebulae, the dumbbell contains knots. Its central region is marked by a pattern of dark and bright cusped knots and their associated dark tails. The knots vary in appearance from symmetric objects with tails to rather irregular tailless objects. Similarly to the Helix Nebula and the Eskimo Nebula, the heads of the knots have bright cusps, which are local photoionization fronts. Central star is a white dwarf. And so apparently an above average sized white dwarf. Anyway, star at its center, which is probably that one right there. White dwarf, but it's been expanding for 10 to 15,000 years. It's been expanding like that. Wild. Yeah, the SE mounts are pretty good little mounts. I actually had an SLT before this one, before I got the Evolution, and I just decided to leapfrog straight to the Evolution, and have not regretted it. It's a great mount. One of the heaviest and most robust AltAz mounts you can get without spending a fortune, of course. And been really happy with it. And it works, between it and the star sense that gets me auto-aligned. It means I can it means I can be aligned really quickly. And no, I don't use a wedge. I am one of the people who's of the opinion that wedges are pretty much there's no reason to go to a wedge. They turn a relatively simple and easy AltAz mount to set up and use into something that's much heavier, complex, ungainly, because it throws the center of balance, the center of gravity of the scope off, and so that's harder to wrestle on and off to the scope and the mount. They're ungainly, quite frankly. If you're going to go to that level of complexity with your mount, you're better off just getting a regular German equatorial mount. Get an AVX instead of putting a wedge under your Evo mount. It's just, I think that's just by far a better option. Even though Celestron does sell the a wedge that's designed to put the SE and Evolution mounts on, the Evolution and SE mounts were not designed to be operated tilted way over on a wedge. They were designed to be set and leveled on the tripod and then used. That's really what they were designed for. And even though they do sell wedges for them such that they can be used equatorially, I don't think they work nearly as well. And so save your money on the wedge and put it toward an AVX, and I think you'll be much happier, personally. It's the same amount of work basically to set it up anyway. You still have to do the polar alignments and the star alignments and all that stuff, so you might as well just get a mount that's designed to be used equatorially, in my not so humble opinion, than to struggle with a wedge. I actually used a wedge before. I have used them, but did not find it to be... I found it to be more of a pain. Its cons did not offset the pros. Obviously, when using a wedge mounted equatorially, you can use much longer exposures than you can on a raw AltAz mount, but still, it's just not worth. If you're going to go through all of that anyway, just get yourself a GEM, like an AVX or one of the many, Skywatch or Ioptron equatorial mounts. The smaller end works just fine. If you have a C8 or smaller to put on it, it's you don't need to have a big mount. Especially if you're doing EAA and you're only sticking to 20-second or 30-second frames at the most, you don't really need to have a big mount. I would imagine an 8-inch Rasa would weigh about the same as an 8-inch Cat, so I think they would probably do fine. But I'm not sure. Well, how much does the 8-inch Rasa weigh? You can get on the Celestron website and find out. I think it's probably similar in weight, maybe a little bit heavier than a C8, but I would imagine it's probably about the same weight. Alright, well there is our dumbbell. That's about as good as we're going to get it. That came in pretty well though, I think. I think that did pretty good. Yep. Alright, well, I think I am going to call it a night. Been on for a little over 2.5 hours, so I think I'm going to call it a night for tonight. So thanks everybody for joining me from Death Valley. This is Mike signing off. I'll probably be doing another live stream here the next day or two with the mono this time next though. And I'll hopefully see you then. Thanks a lot, guys. Good night.